Account for each of the following observations about pairs of substances. In your answers, use appropriate principles of chemical bonding and/or intermolecular forces. In each part, your answer must include references to both substances. Even though NH3 and CH4 have similar molecular masses, NH3 has a much higher normal boiling point, negative 33 degrees Celsius, than CH4, negative 164 degrees Celsius. NH3 has a higher boiling point than CH4 because it has stronger intermolecular forces and will require more energy to break the bonds between the atoms. NH3 has a hydrogen bond, a bond between hydrogen and nitrogen. A hydrogen bond consists of a hydrogen bonding with one of the three most electronegative elements, nitrogen, oxygen, or fluorine. CH4 only has dipole-dipole forces, which is a force between a slightly positively charged and a slightly negative atom. Hydrogen bonds are much stronger than dipole-dipole forces, so therefore NH3 will have a higher boiling point than CH4 because it will require more energy to break apart the hydrogen bond than it would to tear apart the dipole-dipole forces. At 25 degrees Celsius and 1 atm, ethane, C2H6, is a gas, and hexane, C6H14, is a liquid. Both C2H6 and C6H14 contain London dispersion forces. London dispersion forces are attractions between an instantaneous dipole and an induced dipole, which means the movement of electrons causes one end of a molecule to be slightly positive and the other to be slightly negative, making them momentarily attracted to each other. The more electrons something has, the stronger its London dispersion forces will be. Because the more electrons, the more movement of the electrons, and the more likely an instantaneous dipole-dipole moment will be created. So, since C6H14 has a longer carbon chain and a higher molar mass than C2H6, it will have a higher chance and higher likelihood of dipole-dipole moments forming, so C6H14 will have stronger London dispersion forces because it has a higher molar mass, which means there are more electrons within the compound. Since C6H14 has stronger London dispersion forces, it will have a higher boiling point because the bonds between, or the London dispersion forces are stronger than the London dispersion forces in C2H6. So C2H6 has a lower boiling point, so it's a gas at room temperature, and C6H14 has a higher boiling point, so it's a liquid at room temperature. Silicone melts at a much higher temperature, 1410 degrees Celsius, than Cl2, negative 101 degrees Celsius. Silicon is a metallic element and Cl2 is a covalent compound. Ionic bonds are much stronger than intermolecular forces. So, silicon will have a much higher boiling point than Cl2 because the intermolecular forces within silicon are much, much stronger than the IMFs in Cl2 or any covalent compound. MgO melts at a much higher temperature, 2852 degrees Celsius, than NaF, 993 degrees Celsius. Magnesium has a +2 charge and oxygen has a 2- charge. So the compound MgO, 2 electrons are shared between the two elements. Na has a charge of +1 and F has a charge of -1. So in the compound NaF, 1 electron is shared. So MgO will have a much higher melting point than NaF because it'll take more energy and more heat to break apart the bonds between the 2 electrons shared than it would to break apart 1 electron shared between Na and F. So MgO has a higher boiling point, higher melting point than NaF.